Alright, so now we have our transformed graph. We're going to use that to obtain an equation to represent the relationship that we found. Okay, so this is basically obtaining an equation for the straight line graph that we have here. So we'll write a heading here. So this is experimental equation, heading 3. And then we're going to say line of best fit. And if we look here, there's our equation. It's a bit small. I'm going to go up to maybe 200% momentarily here so you can see it. So we have a gradient here. So we have our y value is period is equal to a gradient times our x value, which is the square root of mass, plus our y-intercept. And then we have a separate equation for our error line, and we'll deal with that afterwards. So let's write out the equations below for these two. So I'm going to go back out to 150, or maybe even to 125. So I might just minimize this so I can see everything at the same time. So my line of best fit equation is, I'll insert an equation, new equation, t equals 0.93189, and then times, and now I want square root of mass, so I'm going to write \sqrt space m. And then I want to have the y-intercept, which is positive here. It's 0.012340. Alright? And then I want to get the equation, get the equation for my error line. I might just put in some tabs here so I can line them up neatly. Push tab. There we go. And then I'll insert a new equation here as well. T is equal to, and that one is 0.99795 times square root m. And here we have a negative y-intercept, so I'm going to write minus 0.021315. Oh, by the way, one little annoying thing is if you write your square root m here and you don't push the right arrow and you continue writing, it'll stay within the square root. If you just use your right cursor arrow, that takes you out of the square root. Okay, so the next step is to work out our uncertainties. So uncertainty and gradient. The reason we have this yellow error line is to give us an indication of how much the gradient can reasonably vary while we're still within our error bars. So the yellow line still goes through almost all of the error bars, but it has a different gradient to the red one, so it gives us a sense of how much it can vary. In other words, how big the uncertainty is. So the way we work out the uncertainty is quite simple. I'm going to put an equation in here. So it's just the difference in the gradients. So you just take the bigger one minus the smaller one. 0.99795 minus 0.93189. And we can work that out with our calculator. There's a calculator. We go 0.99795 minus 0.93189. So it's 0.06606. And then we can write \approx, because we're going to round this. And we want to round it to just one significant figure. So we want to keep those two. In other words, it's going to become 0.07. Okay, that's our gradient uncertainty. Then we go uncertainty in y-intercept is equal to, and now again, we add an equation. We take the bigger one minus the smaller one. Note that the bigger one is this top one because it's plus. This one is negative, so we're going to just choose the bigger one minus the smaller one. If you do them the wrong way around, you'll still get the right answer. It'll just be negative. Okay, so I'm just going to take the bigger one, 0.012340, and I'm going to subtract the smaller one, which is negative 0.021315 is equal to, okay, let's do that, 0.012340, and instead of minus negative, I'm just going to take a shortcut and go plus 0.021315, 0.033655. And then I'll go backslash approx, and that is to one significant figure 0.03. Okay, and now we're prepared to write our final equation. So final equation, and I'll insert a new equation here. It's going to be t is equal to, and now we want our line of best fit gradient, which is this one, 0.93189, and then I'm going to go backslash and write PM, which is plus minus, and the uncertainty in the gradient was 0.07. Okay, and now this 7 is in the hundredths column, which means that this is the most, any figure that is less significant than that 3 is irrelevant, because they're all smaller. And because that's a 1, we don't have to round up to 4. So let's get rid of those. So there's our gradient. And then we want to multiply that by the square root of m. And then a forward cursor to get out of the square root. And then we're going to write plus. And now open a bracket. And now we want our y-intercept for our line of best fit, which was 0.012340. And then / PM for plus minus, and then we want our uncertainty on the y-intercept, which is 0.03, and once again that's in the hundredths, so 0.01 stays, the rest of it is smaller than the uncertainty, so it's insignificant. So we get rid of that, and we don't have to round up because it's a 2, and so there's our final equation. So we're nearly there now with everything we need for merit. One last step, and that is to compare this with theory.